Welcome to the latest episode of Math Talk. I'm joined here by my friend, recently minted Doctor James Steele.
Hi, everyone.
So James is graduated under my supervisor. He's in the same research group that I am. But actually we go back longer than that.
Way back, mid-undergrad.
Mid-undergrad,
Yeah.
yeah. So we first met up at the University of Alberta. There was a conference, like a summer school for undergrads.
Undergraduate summer school in algebra and geometry?
Yeah,
Geometry?
yeah, something like that.
Something like that, yeah.
So we first met there. We then met again 2019 at a summer school in Toronto on the homological algebra of
that was
mirror
my
symmetry.
first year of grad school. Were you in?
No.
That was
I was in
actually
my master's then, I think.
before
maybe.
my grad school. That was my last year of undergrad. So.
Oh, that was my
Yeah.
last year. That was the summer for me between undergrad and masters.
Yeah.
And then I ended up here.
Yeah.
Yeah.
I know, it's crazy. Yeah, our lives have traced throughout. It's kind of cool.
Yeah. So, I don't know, maybe do you want to give just like a brief introduction to the things you work on? Will I fiddle with the computer? Just start telling them a little.
Will folks on your stream know about your research or no?
Yeah, they know. Well, maybe a bit, but feel free to yap a little.
Well, essentially, we work on the Langlands program, which is this massive program, which I think anyone who works on it only understands part of it, but I only understand a very small part of it. But it effectively tries to figure out how, with L functions that are related to the Riemann zeta function and the Riemann hypothesis, as an entryway, they can be built through symmetric functions, like some functions off of symmetric things. So like a group would be periodic functions would be the first things you'd see of the circle, and relate those to solutions of polynomial equations. So this has been built up, and there's now a geometric view on it, and using this thing called Koszul duality is what I studied, and it was a way of translating between these two worlds. And it's Koszul duality is this. I think of it as a kind of higher order version of the Fourier transform in a way that translates between these two worlds, but shows up in physics, shows up in other types of representation theory. And so what my thesis was on, that I just defended, was on showing that in the case of p-adic groups, which are one side, the symmetric function side of the Langlands program, that a certain class of representations for semi-simple groups there are Koszul dual to a geometric construction that lives on the polynomial equation number theory Galois side of the Langlands correspondence. So what I'm interested in really though is essentially modeling things using geometry and using equivariant geometry, as it were. So groups acting on a space, looking at symmetries of a space, how to glue together all the symmetries of a space. That what I say is really what I'm interested in. Gets me up in the morning. Well, gets me up probably like 3 mornings a week.
Right.
Yeah.
So after the introduction, I like to take things back to the very beginning. How did you first get interested in math? What made you aware that like math was a thing? Like, was there any people or books or like a camp or something when you were a kid? Something like that.
I'll tell the full story because I think it's kind of interesting. In high school, I always really liked math. I always enjoyed my math classes, and I really like reading about physics and theoretical physics and stuff like this. But I was also a delinquent. As it were. I think I hardly graduated high school, not because I didn't do so well, but because I skipped too much class and stuff like that. So I
failed grade 12 pre-calc.
Well, there you go. There you go. So I did not fail grade 12 pre-calc, but I did pass social studies, which is like, we're in Canada, so that's like our history. I passed that literally with a 51. And like just made it. My trouble with social studies is I could never figure out, like, it was never like, now I realize that what you were supposed to write about was like, these are the economic decisions that led to the rise of the Third Reich. Whereas I would want to be like, Nazism is immoral. And this
right.
Is
that's ethics. That's an ethics.
Exactly, which I now understand is what is philosophy. But didn't really catch that at the time.
Right. I mean, so I don't know if I might have mentioned this on my channel somewhere before, but in my English class, the lowest grade possible was a 35. Like, you could not have a lower grade.
Okay, yeah.
That was like the bare minimum you get for showing up sometimes.
Yeah.
And that was the grade I had going into the final.
Okay.
But then I wrote a 99 on the final, and it skirted me by with like a 51 or 52 or something.
Yeah.
It's a very similar kind of thing.
My life is just a series of events where I go, I cannot believe that all of these things fell into place in such a way that I'm here. But it worked out. Maybe everybody feels that this way. I'm probably just the main character in my own story like everyone else. But, but yeah, anyway, so I always liked math, but I took the minimum requirement you needed for science. And I was good at math and I was good at English. I had a English teacher I liked, so I was good at English. So after high school, I was like, well, I should really do math because I really like math. But I was not a competent person, and I would say not that anyone in high school. There are lots of competent high schools, but I would say that's not the general condition. But I had no idea about how to like look up what was needed to get into a math program. And so I just assumed you needed physics and chemistry. Like that was like a thing. Right. Now I know that they'll just take anyone who off the street. But but
yeah, if you're thinking about math and you're worried about, they'll take anyone off the street. So there you go.
They truly will, because and I'm not joking, because so basically I tried to upgrade my physics and chemistry, still was a degenerate, and still could not get it together enough to go to the upgrading classes. Right. So I dropped out of my upgrading classes, which is a bad look, and was like, I'll just do creative writing and philosophy. So I started in creative writing and philosophy at University of Victoria.
Right.
And was not the best writer, which is clearly a bad fit. And so, but then in philosophy, you have to take logic. And then I had friends that were in physics and engineering and stuff, and I would help them with their physics homework or whatever. So I was like, well, I'd prefer to just do this. So I transferred into actually physics first. For some family reasons, I had to move back to Calgary. So I transferred into physics first, and I was bad at...
Wait, in physics here in Calgary?
I transferred into physics here in UCalgary, yeah. Because also, both physics and math, whereas engineering, I think you need a 97% average to get in. For physics and math, it's like a C. So I was like, oh, perfect. I didn't need chemistry anyways. Yeah. And so, but I'm really bad at calculation. Just really bad at calculate. I understand what I'm doing, but I always skip steps. I'm one of those people. So I was like, well, this also isn't going well. But then I took a class that had proofs in it. And proofs is just writing what you understand. So I was like, brilliant. Okay, I can do this. Right. And so I just okay, perfect. I'll do pure math. And that's kind of how I got into it. It was a series of failures. Right. And when you're at rock bottom, you do a pure math degree.
Right. And you stay there just at the bottom. For the rest of your life.
Exactly. 10 years later, here we go. Yeah. So that's pretty much it. But then really liked it. I was like, okay, I should probably start taking my life a bit more seriously, and got into it. Did pure math. Went went right into a master's, and then COVID hit, so I transferred to a PhD.
Well, yeah. So hang on, but so at some point you got like algebra pilled.
Yeah, for sure. Like,
so somehow you came out of physics. You came out of the logic part of philosophy is cool, and then somewhere along the way.
Well, so the class that I took that had proofs in it was like the second linear algebra course. And I did quite well in that course. And because I kind of just like got proofs, and I feel like that's kind of like a common thing that people find in math, is that you either I always say it breaks up to people who kind of just run with algebra, as you were, right? Or just run with analysis. And I could not figure out calculus to save the life of me. And so I really liked that linear algebra course. Then I took algebra 1 and just loved it. And I think it's just kind of a temperament thing. I think it seems to be that you either naturally understand things as structurally is how I would think about algebra, or you understand things, you like to do proofs using approximations and arbitrary approximations and stuff, and in that case you run with analysis. That is obviously a false paradigm, but it's a good,
first approximation.
Yeah, sure enough. Yeah.
So it's the constant, or maybe what the coefficient of x in the Taylor series expansion that I correctly describes mathematics.
Specifically, it was what really made me into it was the like Galois theory, like just seeing that algebra, a lot of it seems to be, and of course analysis is like it all just boils into the same thing at the end, but you see in a first Galois course like the fundamental theorem of Galois theory, and you see this correspondence between these things that look nothing alike, like with field extensions and with Galois groups, and I was like, wow, that's brilliant. Like I love like seeing unexpected connections or whatever. I think maybe if I wasn't a mathematician, I'd be a conspiracy theorist or something like this, because I love to just like see, like underneath all of this, there's this hidden structure.
So this is something actually that I think I've talked about a lot in my live streams, also in interviews. I mean, this interview probably won't come out for like a month because I try to like space things out.
For sure.
Math content in between, but but this idea that like, I mean, we're these like, we evolved to have these pattern-seeking brains, and like evolution's not this perfect thing, right? So you're gonna lean to be like more or less pattern-seeking, and I guess it's turned out to be a decent strategy that you lean more into the pattern-seeking. So you go heavier into the pattern-seeking, which runs the risk of hallucinating things that aren't there. More, not in the literal sense, but in terms of like, you think there's a pattern, but there really isn't, thinking about, how we thought that, we had to sacrifice the goats or whatever to like get a better crop this year or something. And so all this stuff. And so, I do think a lot about this spectrum of like conspiracyist sort of like level thinking and mathematics. And there's also like this talk about creativity that you need in mathematics. So you do need to make sometimes a conceptual leap in order to prove something or make some progress, right? And so I really do think about this a lot, about where we sit on this spectrum of like overshooting.
That's interesting. That's really interesting.
It's just it's on my mind a lot lately.
I guess I guess there's kind of a lot there, because that's kind of how doing math research works in a way, is you kind of just have to blur your eyes and come up. You kind of have to develop intuition in a way to do math research, and it's in some sense it's a synthetic intuition, because what you're dealing with is such an abstract structure, and you just kind of have to hope that you developed intuition that's guiding you in the right way. Because I'm sure everyone's done this, who's done some math research, is you start working on something for weeks and you think it's great and it ends up just being
completely wrong.
Garbage. Yeah, you know what I mean?
Yeah, so that's the thing. I mean, we even as it is, we end up chasing a lot of ghosts.
Oh, for sure.
And
for sure. And I think looking back, like when I was in high school, I think that was maybe what drew me to physics, because it was, well, obviously we do math, but I still like popular physics. I like reading some physics stuff.
Right.
But is this idea that like underneath our physical reality, there's like this conspiracy going on. That's, you know, whatever, the fundamental equations of physics or whatever it were. Right. That if you could just uncover it, it would be some type of fundamental truth, which I think is in some way, you know, I was just on a different set of message boards than folks that end up in QAnon or whatever. Right. Political conspiracy theories people go into, right? So, but it is something about like finding the unknown, finding like a elegant solution. Because if you think about what conspiracy theories are, like conspiracy theories are a very, very elegant solution to problems of society that happen to often be wrong. But if they were right, it would be a fantastically elegant solution. Right. Because you can sum it up in a tweet or whatever. Right.
And you're like, all we need to do is just like kill the lizard people.
Yeah, the lizard people.
And then like literally all of our problems will like go away.
For sure. Like think about the lizard people example. Like what if the reason for social inequality was that the lizard people were running, you know, Mark Carney and Donald Trump or whatever. You know what I mean? And that's actually what it was. All politicians are just lizard people. Right. Oh, there you go. Elegant solution. Right. I can, you know, people always talk about the fact that you can write like the general relativity equations on your t-shirt or whatever, right? Okay. All politicians are lizard people fixed on a t-shirt. Yeah, there you go. Yeah. Elegant solution. Often wrong. Right.
Often wrong. Some politicians are lizard people.
Yeah. Oh, yeah. Clearly. But that goes without saying. But miraculously in math, we actually have a way to verify this, which is proofs. Right. And you don't like, which I think is the other part that drives people towards math, is because it's like, I'm done with this subjective grading of my genius philosophy essays that say that I don't actually understand what Kant meant or whatever. Right. I'm going to go where I can prove that I know what I'm talking about. Right. So yeah. But that's interesting. I never thought about that. I think there's like just generally like a research mind. Right. Is drawn towards like the unknown or whatever. Right. Yeah. I think everybody kind of has that.
Yeah. I mean, a general curiosity. Yeah. But yeah. So, okay. So that all came from a discussion of how you got to algebra. So you sort of got there by way of, linear algebra and then algebra and group theory. And you were doing all that here. So then somewhere along the line, you encountered Clifton.
Yeah, Clifton was my Gawa.
But actually, this is not who you first started with.
No, it was. I did summer research for Clifton. I've worked for Clifton now for like 10 years. Like, I did summer research for Clifton. Working on effectively linear algebra problems. Like, I was just talking about bridging these two sides of the Langlands program using Koszul duality.
Okay, so wait a second before we get there. Okay, so you're taking group theory. What was the first course that you had with Clifton? Clifton's our current supervisor.
Yes. It was
kind of your ex-supervisor, because you're now technically done.
Although,
yeah, you've got this other project and stuff.
Yes.
But you're technically in like a no man's land.
For the next 2 weeks. But, except for revisions, which are hell. But
Yeah.
so the first course I took with Clifton was algebra two.
Right, that's Galois theory.
Galois theory, yeah. So it was Galois theory, and then Clifton taught. I had to take a number theory course, and Clifton threw out the Fermat's-Little theorem and Dirichlet equations.
What's supposed to be introductory, like modular arithmetic.
Yeah, sure. Like what I think the Russians do in like grade 2 or whatever.
Right.
But and that was affectionate to any Russians that are out there. It wasn't meant to be pejorative. But like in other countries for sure, number theory I think is you do learn it quite early. Like like looking at equations of like a to the n equals b, when do primes satisfy, this kind of thing.
Right.
And he was like, L functions. We're going to learn Tate's thesis in like a second year number theory course.
Right.
And I had no idea what was going on in that course whatsoever, but I was like, this is great.
Yeah.
This is it. This is the underlying these two fields of math is this secret structure that nobody understands called L functions, that we can hardly prove that they satisfy all of the properties we want of them. This is great. And then so and so that's how I met Clifton. That's how I started working with Clifton.
So then you did summer research with him.
Yeah, I did summer research with him, and my summer research was to prove that you could write a to prove that in an abelian category you could find a object so that the endomorphism algebra of that object gives you the entire category, which probably means something to like hopefully one person listening. But
so just like the progenerator?
The progenerator, yeah. So it was basically, there's this category, which was Braden's category, but the category of all perverse sheaves, which Chris has on.
Wait, Braden's category?
Yeah, like Braden shows that the category of perverse sheaves, not equivariant perverse sheaves, decomposes as the direct sum of
a bunch of categories that are equivalent to module categories.
Exactly, but they were quiver categories, and the way these categories are defined is not they're not finite dimensional algebras; they're infinite dimensional algebras. Right. So it's not clear that you can use all of the tricks from finite dimensional algebras to get your hands on them.
I see.
And so I basically, but that's not going to mean anything to people, but I was basically just doing linear algebra problems.
Right.
Yeah, and I don't think I ever learned linear algebra the right way. So effectively my summer research was like finally figuring out how to properly understand linear algebra.
Right.
I would say, yeah.
Nice.
So that was that. Yeah, started my what was then my master's on the same project effectively, but to bring in more structure from either side of the correspondence, the Langlands correspondence in. The rest is history, and then I just kept on working on that. Worked on the quivers a little bit, but
we don't have to go into it if you don't want to.
No,
I thought you worked with someone else for.
Oh, I did. So I worked with my erstwhile co-supervisor.
He was co-supervising.
He was co-supervising Clifton. Yeah.
Right. Yeah. I see.
Yeah.
Okay, so it started off. Okay, so you did your summer research with Clifton.
Yep.
Then you start a master's.
Yeah. Yeah.
And then at the start of the master's,
and so at the start of the master's, I was being co-supervised by another professor in the department. He had just come in, and he was he worked on these things called D modules, which is the algebraic interpretation of differential equations, and we work on these things called perverse sheaves, which are the geometric construction of the polynomial equation side of the Langlands correspondence, the Galois side, as it's called. They're Galois groups that we were talking about, the perverse sheaves are basically the solution sets to the differential equations of the D modules, or the analogous structures on either side. And so he worked on D modules. So he asked if he could co-supervise, because he was coming to some seminars and stuff. And then
he asked to co-supervise.
Yeah, well, I think I don't think it was anything special on my part. I think he was a new professor that needed some students.
Right. Yeah. Get some experience.
Yeah. And then
but that's still that's interesting. I didn't know that.
Oh yeah. So but then COVID hit, and I don't think I was so motivated. And then after a while, I decided to just go with Clifton.
Right.
Yeah.
And then. Yeah, and then you also decided to transition into a PhD.
Yeah, so
how did that happen? How did you decide that? How did that all work here?
Here, basically, I just had to write a document that talked about the research I had done so far. Again, COVID hit, so I was just sitting around doing math research, basically.
Right.
So I had gotten further than I had anticipated. Namely, I'd shown that. I had shown a result that now I think is just clearly widely known, but that any category of equivariant perverse sheaves satisfying certain conditions is equivalent to a category of modules over a quiver algebra, or a path algebra of quiver. And so initially that was supposed to be my master's project, and I finished it in a year. So I was like, well, if I've finished this project in a year, this is what I think I could do in 4 years if I was allowed to do a PhD. And so I had to write a document outlining how I plan to prove this. It was like, 30, 40 page document, which now...
30, 40 pages? I mean, I guess that's kind of just like your candidacy?
No, well, shorter. Maybe it didn't have to be that long, but I wrote out sketches of everything I had done. And so one of the things I had done is I had... I never ended up writing any of this up, but I had cooked up like a growth and deque topology on the category of... So if you look at... You can build a category of quivers, which is just directed graphs. Hopefully that means something. So on a category of directed graphs where your morphisms are injective maps of graphs. So effectively you're looking at a category of open sets for a graph. And I show that you can put a growth and deque topology. You can use that to get a growth and deque topology. So that becomes like open of X, if people know sheaves. So that would give you a growth and deque topology on your category of quivers generally that lands in path algebras. That you can like glue together path algebras. And that comes from a observation that I still to this day can't sort out, that like all of the quivers that appear in the Langlands program seem to like glue together in a way that is reminiscent of the representation theoretic or geometric structures using our interpretation of the Langlands program that we work on. That I still haven't ever been able to resolve. But I can resolve it for arbitrary quivers, but I can't relate it to structures within the Langlands program. So I kind of dropped that. Anyways, back to this document. I look back at the document probably a year ago, and it's total rubbish.
Right.
Like it's just completely wrong.
Yeah.
But well, that result in quivers is right, but what I said about the Langlands program is totally wrong.
Yeah.
But thankfully, I don't think anyone read it that well. They were like, well, we'll let James do the PhD. That's fine. Whatever. Yeah, we need TAs for the next 3 years, so that's fine. Yeah. So anyway, so I transitioned.
I mean, this is also something I think. This isn't like directly related, but like sometimes, I don't know, people are asking me about reaching out to supervisors or talking about like applying for PhD programs and like what to say in your introduction letter. And like, okay, look, there's definitely there's like, there's some kid in, where was it? For some reason, I want to say Brussels, but I don't think it was Brussels. Anyways, he he like just graduated with a PhD in quantum mechanics at the age of 15 or something like this recently.
Really?
Yeah, it's crazy. Yeah, but anyways, other than like these geniuses or people who are going to like top 5 schools like worldwide, like most people, you don't know anything about the area that you're getting into, right? And I think most people know that. Like yes, you should try in your like letter, your statement of purpose or whatever, like try and convince people that you know something about the area and like oh, here's courses I've taken that are related to it, I'm interested in. But I think most people understand that like you don't know the first thing about what's actually going on at the research level, right?
100%.
And so I think this is the same like probably a combination of two things happened. One, probably a bunch of people, the people who looked over your proposal didn't know enough about the Langlands program to know that what you were saying was totally wrong. And two, even if they did, they're probably like, well, I mean, this guy obviously he knows enough, about as much as we would expect like an undergrad, early grad student to know.
Yeah.
Because they're just not reasonably actually going to know what's going on, but they clearly have done enough research to like come up with some sort of feasible game plan.
100%. Something that really caused a paradigm shift in the way I think about specifically grant proposals, which is something you worry about more towards the end. But in terms of reaching out to supervisors or whoever your audience might be asking you about, first of all, if you want to do undergraduate research, every single prof on the planet, which is an exaggeration, but most profs will be like, heck yeah, I need someone to do all these crappy calculations I don't want to do.
Right.
So generally,
Right.
they will try to make sure that you can do undergraduate research. One. Secondly, yeah, it's a bit harder with a PhD in math, but it's not specifically in pure math too. It may be a bit different if you want to do, I don't know, like employable disciplines, let's say, like biostats or something like this, maybe. So let's caveat that. But definitely in pure math, if you just show an interest for something, and I think most people will be open to at least having a conversation with you. And like, especially in math becomes so isolated in a way. Like, recently I've been going to some physics conferences, like 2, and you really get the sense that more people know what each other are talking about, because one guy can be like, oh, I look at like how much these two stars are moving away from each other,
right?
And then the other guy goes, oh yeah, I know what a star is,
right,
or whatever, right? And that's totally belittling to physicists.
Yeah,
and I know that they do really important work, but there is a bit more of a common language,
right.
Whereas if we go to a conference about just the Langlands program, first of all, you can't even go to a conference just about the Langlands program. You have to go to like a conference about geometric or categorical perspectives about the Langlands program.
Right.
And even then, I'm lucky if I understand half of the talks that are going on,
right.
Which is maybe my deficit in keeping up with reading. But okay, so maybe someone more intelligent than me is 65%, but still, whatever, right? So any prospective supervisor is just going to be, if not flattered, just stoked that somebody else is keen to talk about the things they like to talk about, because usually they're writing to an audience of like 5 in their papers, right? So do not hesitate to reach out to people. Like, what are they going to say? No.
Yeah.
And then you move on to the next one. Yeah.
I mean, I will push back a little bit, because definitely you want to try to go to like bigger schools or whatever, and like definitely there's a lot of people applying to work with the same famous profs, and definitely as a famous prof, like you want to take the smartest kid you can that's actually going to like help you with your research. But that is not to disagree with your point of you should just reach out to anyone anyways, because the worst they can say is no, or like ignore your email.
Yeah, to be clear, I'm not saying that I'm not trying to say that it's necessarily easy if your goal is to work with like a Fields medalist or something.
Yeah.
What I'm trying to say is it's also not as hard as, I don't know, like breaking into like the financial industry in Wall Street or something like that. Like these.
What, is that true? I don't know. How hard is it?
I mean,
I guess quant jobs are pretty hard to get.
That's what I've heard. I don't know. Well, maybe not. Maybe that's a bad comparison, but I don't know. It's not as bad as you think it's gonna be. Right. Is basically what I'm trying to say. And even if you don't get that person, if you want to work with a Fields medalist and you reach out to them, one, if they don't respond, don't take it personally. I'm famous for always forgetting about emails and stuff. Two is, if they do respond and you have a conversation with them but they reject you, then that still just gives you the experience of talking with someone like that and honing those skills, and eventually you'll get there. And people aren't looking for you to be, it's not like the people above you in line are like, oh, I actually won a math competition for high school students when I was 6, and I've just been working on hard problems since then. They're just people like you that are also just trying to navigate their way through grad school and figure it out. So,
well, no, there's both.
there's both, but
there's
certainly not even an impressive minority. Let's put it that way. Most grad students I've met are more similar than not, I would say.
Right.
Yeah.
Yeah.
So I don't know, but also think about funding. Like, don't take positions where you think you're gonna have to live on rice and beans exclusively for 4 years or 2 years.
I'm sorry. Are there any positions where you don't have to do that?
Well, supposedly when we like
no, we're not that poor, but
we're
pretty poor. We're pretty poor
compared to the States. Canada definitely has a disadvantage, I would say, in our funding positions.
Right.
Yeah. But even there, that's just about grant writing, and more to that point, you're going to end up writing government grants, and the best. And I was just about to talk about the paradigm shift with government grants. So effectively, especially with theoretical fields, the government doesn't care what you're working on. What they care is that you are contributing to a community that is going to produce people to work in research or high value fields within the economy. And so you just have to write something convincing that says that you're going to be able to work on hard problems and stuff. And that really gave me a paradigm shift in how I write grant proposals. So it's worth it to pay attention to those details, because I think I only started paying attention to details like grant proposals and stuff like that like a week ago.
Right.
I think I'm better off right now.
Right.
Yeah, for sure.
Yeah. Okay. So you did became a PhD. Wait a second. But right. So you explained why and how it transferred into a PhD. So then you've been doing your PhD for the last couple of years, which is what you mentioned briefly what that's all about at the very beginning. And then. Well, so now here we are at the end of the PhD. What's next up for you? What are you working on?
Well, so again, still working for Clifton, but now in a postdoc position. But it's not just for Clifton. It's with this kind of consortium. So it's with this startup from Vancouver. It's with the kind of quantum group that University of Calgary has. Quantum, well, I actually don't know to what extent they're associated. They're associated with University of Calgary, but it's called Quantum City here. With MyTax, which kind of puts you in partnership with industry partners, postdocs in touch with industry partners, and with the National Research Council, it's called, or Canadian government's like in-house research facility. And so between those, so I basically now I have 3 supervisors. So my second attempt at co-supervision. We'll see how it goes. But now I'm working on more quantum computing stuff, as I said, which again, in terms of phrasing grant proposals, I'm working on quantum computing as far as the government knows. like nudge quickly.
Yeah, should I be cutting this out before this?
No. It is. But miraculously, that geometric structure that we work on to model things, like the geometry I was touching on before, that we use to model things in the Langlands course and the Langlands program. Miraculously, it's the exact same thing that they use to model the quantum group, from which you can build algorithms and stuff like that. So I'm still working on the same geometric model. Now I can just call it quantum computing instead of the Langlands program, which was a good.
So wait, this is somehow through like the geometry of the nil cone relating to quantum groups or something.
Yeah, exactly. So basically ours. So this is probably, I'm just talking to Kristaps now, I guess, but to explain it briefly to you.
I mean, we got people on this channel who.
All right, cool.
Who know
so
more than me.
You take a quiver variety. So we could look at the case for GLN, right, for p-adic groups. So you take a quiver variety. So what you're doing is you're taking a representation of a quiver. So for GLN, I'm just thinking of a series of vector spaces with equivalence classes of linear transformations between them. So basically effectively the same linear transformation up to a scalar or something. And so the dimension of the vector space is fixed, and the ranks of all of the linear transformations are fixed, as well as the compositions of all those linear transformations. Okay, which Chris helps know as well, but I just want to kind of set the stage.
Yeah,
and this helps me hone my elevator pitch, I guess, for a very long elevator ride. And so so that forms a variety, and then you look at certain symmetries of that variety that are built from a related group, and that classifies the irreducible representations that show up in the Langlands correspondence for p-adic GLN, with some adjectives that I didn't add. And okay, so what we look at, or what is the driving focus of this, is we look at the conormal bundle to that. And so the conormal bundle to that is the same thing, but it's just two copies of that vector space, but where with the same group acting, but where now that you have two copies, you have to figure out how the group is mixed, right, on the conormal bundle. And that turns out to be a representation of what's called a pre-projective algebra, which is a well-studied class of quiver or path algebras of quivers, because they model the quantum group. And so effectively, where we
with the quantum group,
or a quantum group,
right?
I should say.
Okay.
So essentially, the convolution of perverse sheaves that corresponds to the tensor product of representations on the conormal bundle now corresponds to the convolution of functions in the quantum group, or the Hall algebra, or the Heck algebra, whatever, Heck algebra with the quantum parameter, whatever you want. And so the more or less the exact same geometric structure, but you can use it to derive the positive bit of the quantum group. So you can get all of it from it, but so you can get the quantum group, and then you can get topological quantum field theory and fusion categories and all that from it, and in ways that I don't fully understand right now, to be honest, but plan to understand very soon. Is you can build hypothetical error correction codes for quantum computers, quantum algorithms, that kind of stuff, from looking at the convolution structure on this geometric space. On the conormal bundle of the Vogel variety, as our parlance would classify it. Yeah.
Right.
Yeah. So more or less, that's what I'm working on, and then some some other stuff before, but that's what I've been thinking of most recently, I would say. Yeah.
Right. How the hell did that come about?
Well, Cliff and I were just talking about if we could work some more together, and I was like, well, so I'm my partner in Calgary. She owns a daycare center, and so we're very tied to Calgary. This is uninteresting, but for various reasons, it's hard to move a daycare and hard to start a daycare outside of Alberta. And so we're very tied to Calgary. I wanted to do a postdoc, but I wanted to keep working on stuff, but I was like, well, the time has come that I am going to exit mathematics. So I was looking at doing quantum computing. I was looking at there's a lot of money flowing to Calgary for at least government money to do quantum computing. So I was looking at that a little bit. I was thinking more probably get a job at a bank or do data science or whatever. I don't actually know how the industry works whatsoever, so I'm just saying words I've heard. So I was just having coffee with Clifton about it and chatting, and he was like, well, what if we could get you a postdoc here? And I was like, oh, that's nice, but essentially you can't do a postdoc through most grants. You can't do a postdoc at the institution you did your PhD at, except for my tax if it's with an industry partner. And so we're working with Clifton's former student Samuel Reed, who started a few companies, but he's down to work on kind of high risk, high reward concepts in pure mathematics that could have some type of industry payoff someday. And so we're working with him, working with my docs, working with quantum computing researcher from the National Research Council to work on this project. And there's some other stuff like so there's connections actually between in another way to build quantum gates, there's connections between the Vokenich project quite directly actually, because some number theory shows up there and you need some like L functions and stuff. So we're, we've been throwing around ideas like that. That will actually probably be the first place we start, but that's essentially how it came about. And so I said, well, that's great. For those of you who are looking to do a postdoc, industry adjacent postdocs pay a lot better than just government postdocs or other. And so that was a concern. Like I said, we have a new baby and stuff. So so I said, okay, heck yeah, let's do this. Then I can keep working on the geometry I like for at least 3 more years. And so effectively my entire life
is a 3-year postdoc?
It's 3-year postdoc, yeah.
Oh, nice.
So my entire life has just been trying to do the things I like to do for just a few more years.
Right.
And then I'm like, and then after that, I'll get a real job.
Right.
So at the end of this postdoc, it may finally, I really think I've stretched it as far as it can go.
Right.
But yeah, so that's how it came about. So to this day, still have never, outside of bars and coffee shops, I've never had a real job, as it were. And I fully respect people that work in coffee shops. Working in a coffee shop, I maintain, is way harder than doing a PhD.
Oh, absolutely.
Because you're freaking exhausted by the end of the day.
Yeah.
In a way that you're not in the PhD, physically exhausted. So this is a way of me just pursuing my interests for another 3 years, which I am more than happy to do.
Nice.
Yeah. I'm sure you'd make more money if you work in banking, but not have as much fun.
Right.
And I don't go in a Patagonia vest, so.
No? Don't you have a Patagonia vest?
Well, I have a coat.
Oh, you have a coat. Well, you have a vest. You were rocking a vest for a while, were you not?
Oh, I do have a vest.
Yeah.
I just don't think I look very good in it.
I don't know. I think...
I don't like wearing collared shirts. That's another one.
I see.
Yeah. Or having fixed timetable.
Right. Yeah.
I have enough time showing up for the class. I have to teach on time. If I had to show up to 9 to 5 every day, or not 9 to 9, whatever bankers work, I think I'd be in it for a rough go of it. But.
Yeah, that's actually, so I just did, so today, on the day we're filming this, which is like probably a month before this comes out, I released an interview with someone. And then also this morning I did an interview, so I was being interviewed on his channel. So we sort of interviewed each other for each other's channels. Anyways, and yeah, one of the things we were talking about, is I think was about the like cushiness, the actual cushiness of like the mathematical life. If you think about it, like
great.
Yeah. I mean, yes, there's this like, publisher perish and like pressure to produce and stuff, but it's also like right now I just have like, I'm just managing the math help center here.
Yeah.
And so that doesn't have any specific schedule, like unless I'm filling in for some student who's sick or something. So it's like, yeah, if I feel like it, I can just lie in bed all day long and just like think about math and just like blow off other things. Or if I don't want to think about math, I can just watch the latest season of Squid Games or because I'm just like, I don't want to work today. I mean, okay, that'll get you in trouble if you do that too many times, because then you'll be out of a job because you want to produce enough papers. But
well, that's something that's distinct to math too, though, right? Is that in math, whereas if you're doing a chemistry or biology PhD,
right,
from what I understand, and again, got 51 in social theory, got 51 in bio 30.
Right. Take these words with a grain of salt, maybe.
But from what I understand from talking to our colleagues in those departments, is that PhDs there are basically like a 9 to 5 job.
Right.
Like you have to show up.
Right. And
if you're not there when the amoeba comes out of the egg or whatever it is.
Wow, 51? I'm impressed.
Yeah, what is the mitochondria is the power.
Yeah, because when the amoeba hatches from the egg, it needs to see you first, so it thinks you're the mother for the experiment.
Yeah. I think that was probably like a sci-fi short story.
Wow.
But okay. But whatever the heck they do, I understand it's time sensitive is the point.
Yeah.
And
and there's also the fact that like because there's just a physical lab, there's so much other stuff that you can and need to do, like general upkeep of the lab, just even make sure things are like clean and prepped, or like checking in on an experiment every day. It's like there's physical things that you can do and in fact need to do every day.
Yeah.
Whereas this is just like not the, like in math, our laboratory is our head, is our notebook.
Yeah, exactly. Which, in fairness, if you want to do well in math, treat it like a job and try to be writing as much as you can in the time you're not teaching. Word to the wise, because I feel like I wasted probably 3 years by not doing more of that. But
I mean, to be honest, there's been a lot of postdocs I've met while I've been here, and a lot of them have had the habit where they treat it like a 9 to 5.
Yeah.
And they're in the office 9 to 5 working, and then they take weekends off. Which is not my style of doing things at all. But then part of me is like, well, these people did make it to the postdoc level for a reason. So I don't know. Maybe I should be taking after them or something.
Yeah. Or you're like me and you just have this like 10-year grift going on with the University of Calgary.
Right.
Either one. Right. But yeah, no. If I did notice, like I think I approached entering a PhD thinking that one day I was going to have a strike of inspiration, figure out how to prove my problem, and then I'd be done.
Right.
And that's what it was about. But that's not what it's about. Because my actual PhD thesis, I'm kind of like mid on. Like, I'm like, oh, this is interesting. But I like have others, like, while I wrote my PhD, there were other things. And in fairness, one of them was the second half of my PhD, which I like a lot better. But there were other things that came up that only came about because I had to read a little bit about, homotopy theory to prove a lemma or whatever. That then made me realize a new connection that then has another paper that I'm more excited about. And had I done that earlier, then my actual thesis could have been about those papers that you're excited about, right? So if you start doing this stuff, and there's a kind of gray area at the start of, like, maybe the first 2 years of a PhD, you're kind of just figuring out how to understand what's happening. But once you have a good idea of your problem, once you have a good idea of what you need to do to solve your problem, I would suggest trying to write as much as possible.
Right.
Yeah.
Right.
Yeah. Yeah. Because that's the best way to think, I guess. Yeah. But then there is, it's a bit of that, I don't know. It was like Bukowski or something that said it like write drunk, edit sober.
Oh yeah.
Who was that?
Yeah. I mean, that sounds like a Bukowski type quote.
Anyways, I'm not a Bukowski fan or stan or anything, but
I was for a while. I remember there was one summer, speaking of being a degenerate, this was like in between. This is when I wasn't in school at all, and I was just partying literally every single day. And I remember one day I just got day drunk on whiskey, which is the exact vibe, because Bukowski was just some drunk. So of course you're gonna think his poems at its deepest when you're also just being a degenerate and day drunk. And yeah, I remember I read this one book of poems. Play the piano drunk loudly until your fingers bleed a bit.
Yeah, totally.
And I was I thought this was the greatest thing ever at the time.
For sure.
It was probably just because I was being a drunk piece of shit. So of course this other guy who was a drunk piece of shit, I was like, oh yeah, man, this guy's his words are for real.
Totally. Well,
not to say I'm a Bukowski stan now or anything.
It's because when you're 19, you're like, these are some deep truths, and then 10 years later you're like,
what an asshole.
Yeah.
Yeah, embarrassingly,
sometimes misogynists have good quotes, I guess.
Yeah. I mean, I was also a little older than 19 at this point too. But
yeah, well, whatever. We all come enlightened at some point.
Yeah.
But yeah. Anyways, so the benefit of math is the creative part, that you do have to go around and think about it. Right. But then I would try to spend some time writing. Like a writer that I still like to this day is she's a photographer her name's Sally Mann, but she writes these memoirs too that are really good. She's a new one out called Art Work, like art space work, and it's fantastic because it just talks about being a working artist, and that it's not about inspiration striking you. It's about getting up every day, treating it like a job. She has a husband who's a civil rights lawyer, kind of a public defender in the U.S. for a small, I think they live in Louisiana or something. So for the small courthouse or however it works, I don't know. Hopefully that's a bit more cogent than my take on biology. But but she talks about it as this should be a trade, and I think that's kind of how we should teach mathematicians to do research, is more as a working trade. Rather than being so in our heads about this ivory tower idea. It should just be kind of working every day towards something to really do something rather than just talk about ideas.
Well, actually, I think half of mathematicians are already doing this. They're called applied mathematicians.
Oh, for sure. They're called employed.
Yeah,
exactly, right? Yeah, but I don't know. It's the classic mistake. My brother is doing a PhD in English, literature, and we were talking, and he made all of the same mistakes in a field that's quite far away from math. So I think this is universal to doing a PhD is kind of maturing in this way.
And he made those mistakes first, and you didn't learn from them.
Well, he's younger than me.
Oh, he's younger than...
But yes, he did make those mistakes first.
But he made the mistakes first anyways?
Well, he did a master's before he did his PhD. I think I kind of would have benefited from actually finishing the master's. To actually kind of go through that process of having to write something. Yeah. Because I didn't really have to write anything until 2 years ago when I wrote the paper on what we published for the thesis, or
Right.
sorry, when I wrote the paper about what I wrote the paper based on what my thesis was on before I wrote the thesis, and that was the first time where I was like, oh, like this is what it's like, and like there's like parts of that just don't come out in just the like pontificating process, or as it were, right? So yeah, but it is really interesting how that realigns your thinking, you know. And you know, I don't know. I think philosophers and poets have been writing about this since the dawn of time, about how writing, like, you know, channels different lines of thought or whatever. But it is interesting to have that experience while you're doing your PhD to see it happen in practice, I guess. I don't know if you write all the time, like Chris Abs. I'll have a conversation with Chris Abs and like take the bus home, and he'll be like, okay, I think I sorted it out. Here's a 4-page document. And it's been like an hour. And so, yeah, it's a bit of an exaggeration, but I think Chris has to sort this out, so maybe he doesn't.
No, I mean, it's kind of true though, but I sometimes I feel like I need to write things up for myself in order to understand it, you know, like, yeah. And
but that's my point.
Yeah.
You need to write things up to understand them.
Yeah.
And I'm seeing that that's not clear when you start a PhD. Yeah. So I guess that's my like warning to people. Like, start writing.
Yeah, I think Federico has a good story about this. I don't know if I should try to like butcher it here, but yeah, something about how his supervisor, like in his master's, kept pressuring him to write stuff down, and he's like, oh, I'll just do it. Like, no, I need to think of all the ideas first. I need to finish the proof first, and then I'll write it all down, which of course is a horrible mistake.
That's the carriage before the horse, for sure. Yeah, like, well, it's both.
And then of course, it got to that point in time, and then he realized it was a horrible mistake, and how right his supervisor was, that he should have been writing the whole
And
time.
in a way, that's why it's kind of good that Canada does have, like, I really do wish I did a master's program before I did my thesis. Like, I think it would have been beneficial to go through that before I like do a PhD. But here I am.
C'est la vie.
All's well that ends well.
Yeah. I mean, plenty of places don't have a master's first, and they're fine, right? Like the States.
Well, yeah, but look at the States.
Yeah, but like
Clearly, because they don't have a system where you do a master's in math before you do a PhD in math.
Yeah. Well, there we go.
And we're ending on a conspiracy theory.
Exactly. Yeah. We really hit a good note.
Yeah.
I don't know. Do you have any other like parting? I mean, I think we've hit across a lot of wisdom, probably a lot of stupidity too. But do you have any like parting words for our viewers here, maybe young, hopeful undergrads or something?
Before you start your PhD program, if you are in the States where you're disadvantaged to not be able to do a master's first, or master's or whatever it was, make sure you understand what the funding structure is, what grants are available to you, and how much you are going to make as a baseline, how much you have to pay for tuition, and what your budget can be like. And if it's not enough, then apply for a school that will give you the funding you deserve, because that was also something that I wish I figured out a long time ago and kind of had to figure out on the fly. And it's a lot easier if you start getting through the process of grant writing and all that at the start of your PhD, and make sure that you get competitive offers.
Right.
That part is better in the States. Like the States generally, and I'm sure folks listening in the States won't feel this way, but in Canada, the funding situation is nowhere near as good as it is in the States. Like at the States, I was looking at postdoc positions that were like $85K a year USD, which is wild. Like Canada's standard for a postdoc is like 50K Canadian. which is I don't know, like $13,000 US.
Yeah. Yeah. I mean, you do have to adjust a bit for cost of living, but I think even then, I remember we were at a conference together. Not this past summer, but the one before, Koszul, right? It was the one before.
Oh, in San Francisco.
Yeah. Yeah. I just remember talking to a lot of the other American grad students there, and they were like complaining about their wages, and they were saying how much their wages were, and I just remember looking at James and I'm like, oh, they're complaining about that amount of money, and I'm like trying to Google, I'm like, okay, cost of living in this city, and I'm like, yeah, okay, it's more expensive, but still, totally. Do you guys have any idea? Like, you're talking about USD. Do you have any idea?
It felt like they were complaining about, like, oh, we can only have caviar on Tuesdays.
Right.
Or whatever, you know?
Yeah.
So, but it is what it is. So, sort out that funding before you do.
Yeah. Okay, well, what powerful words of wisdom to leave off on. So, thanks again so much for...
Yeah, thanks for doing this. It was super fun.
Yeah, for joining me. If those of you who don't remember, there's some live stream where James appeared as a special guest on that live stream.
We
so
do some office hours soon again.
Yeah. So look forward to that, everyone. And with that all being said, QED.